So we've come here to look at some internationally rare and amazing features at Wairere boulders in the Hokianga. The story of their origin goes back about 2.8 million years, when this area was land right across here at about the level of the hills. And a lava flow, a basalt lava flow, poured out and spread right across that land. Then we've had 2.5 million years of erosion that's produced this valley system here. So the stream got through the lava flow and started to erode down the valley, and progressively over those 2.5 million years the valley has been eroded into the soft mudstones that underlie the lava. And as it got through the cracks in the lava, eventually the lava blocks started being undermined and flowing down the valley, and then started to slide down the hills and into the valley as it developed. And so we see today just remnants of that lava flow forming the skyline crest up there. You can see a large boulder on the tops, which is part of that lava flow in situ. And coming down the hill, we can see some of these big blocks of basalt lava that have fallen off that lava flow front and are sliding down the slopes and ending up in the valley. Well, here I'm standing next to a grey boulder. Just look at the surface here. It's beautifully fluted. Now, fluting like this is usually found in limestones and marbles, which can be dissolved by slightly acidic rainwater. So we call this kind of feature karst, and it occurs in limestones around New Zealand and the rest of the world. But when we look close up at this rock, it's not limestone. It won't dissolve with slightly acidic rainwater. It's actually basalt lava from that lava flow that we were talking about. And yet it's corroded into these beautiful vertical flutes, as we can see here. How might this have happened? Let's have a look up on top. It might give us some clues as to its origin. Look at this miniature landscape here. It's corroded into peaks and troughs. Very occasionally you see this sort of miniature landscape on top of limestone boulders, but only in a place like this do we see it formed in the top of a large basalt boulder. It can't have been formed by fast running water in a river. It can't have been formed by physical means. It appears that it's somehow corroded or eaten away to create these depressions. So one has the impression it's probably water, but the water wouldn't usually be acidic enough or corrosive enough. And the answer comes if we go and look in the bush. Boulders like this usually have a growth of small trees and shrubs growing all over them. And you can't see the rock on the top because it's got the leaf litter that's built up all around. And we know in that leaf litter over time it breaks down into humic acid. And that weakly acidic acid could very well be eating its way into the basalt and creating these depressions. And when rain comes down, the slightly acidic water would be flowing over the overflows and down these little valleys, and very slowly over not just thousands of years, but tens of thousands of years to create these features. So the interesting thing, of course, is that these big blocks of basalt lava come from that lava flow right at the top of the valley system here, breaking off and very slowly sliding down the slopes to where they are now in the valley. It would have taken them a long time. They may have slipped a short distance and then been held up by big forest trees and stayed there for hundreds of years until the tree died, and then moved on when the tree died and fell over. So every time it rains in winter, the muds swell up a bit, and those boulders that are sitting on them tend to slide down a hill a few centimetres each winter, unless they're held up by a tree. And then in summer they stand still, next winter they may move a little bit further. So you can well imagine it could have taken tens of thousands of years for each one of these boulders to come down the hill. It's during that slow descent into the valley that we think this production of karst features developed under a forest canopy, maintaining their orientation as they slid down the hill without rolling over at all. While many of the boulders have vertical fluting as they're coming down the hillsides, many of those that have ended up in the valley floor seem to have tilted a bit, or tilted right over when they've come to rest. And this is an example. You can see these flutings that would have been vertical for most of its ride down the hillside, and as it's come to a stop, it's managed to tilt over like this, and the flutings are no longer vertical. This big boulder, look how huge it is, yet it's got this fluting vertical coming down here. But if we just walk around the side here and look down this side, the fluting here is horizontal. So we've got two sets of fluting that have been made at different times. This is obviously the older set, and so the boulder was 90 degrees round and the fluting and water was running down that way. And as it was coming down the hill at some stage, it's tipped over, and now in the latter part it's developed the vertical fluting that we see here today. Well, here we are on some of the bush tracks through Wairere boulders, and look at this amazing example. This is actually basalt rock, and yet it almost looks like tree roots coming down here. All the fluting produced by that slightly acidic humic acid that must have been dribbling down these runnels to produce this over thousands of years, and even more up there. Now, these features were seen decades ago by geologists, and many of them couldn't explain them straight off. They came up with a number of different hypotheses of how on earth could you get basalt, this hard inert rock, dissolved into these karst features. Basalt karst like this is known in other places around the southwest Pacific and in the northern North Island. I think our new hypothesis of how this was formed by humic acid collecting in those bowls on the top, etching them out, and then the runoff coming down the side over thousands and thousands of years, dissolving these runnels, this fluting, is probably the most simple and easily explain all the features we see. Here we are at the lookout at Wairere boulders, looking out over the small stream valley just full of giant boulders that are karst basalt. These boulders that have come sliding down the hill slopes over those tens of thousands of years. And when they get to the valley, they just fall in. And so many of these have the fluting. Some have them upright vertical, but others at various angles where those boulders have tipped over. These boulders, some of them are huge, 5-10 meters across even. And for most of the year, the stream just flows along underneath the boulders and you don't see the water at all. It's only in the very biggest floods, once or twice a decade, that the water is so rapid and high that it actually flows over some of these boulders as it comes down the valley.